Hello. Honors algebra. And level 2 algebra students, we're getting ready for our big test on Tuesday, and I thought I would take your review sheet and just go over it. So if you're watching this early, make sure you've tried all the different problems. Then you can come back and watch the parts of it that you still need help with. The first part is to graph exponentials, being sure that you know how to describe the exponential graph, including, but not necessarily limited to, stating the equation of the asymptote. Remember, it's going to be y equals. Some of you are writing just asymptote equals. That's not acceptable. The linear equation is y equals, not x equals, y equals. Right? Describing if the curve will approach the asymptote from above or below. Okay, and of course, accurately graph the exponential equation. So there's the three equations, and I've got them here with some graphs. There they are. Okay, this first one here, I know there's going to be an asymptote at y equals 1. Yeah, that's the asymptote. Equation of the asymptote. Let's do it in orange. So my asymptote is going to be at y equals 1. Oops, not negative 1, positive 1, sorry. And I'm going to get an imaginary boundary when y is 1. That's a horizontal line. Well, asymptotes don't always have to be horizontal lines. It's just in these equations they are. Okay, now, let's see here. I think that this is going to approach from above because my base is positive. Now, the fact that the exponent is a negative x, I've got a feeling it's going to be reflected across the x-axis, or y-axis, excuse me. A lot of times our curve looks something like this, right? I think because my x is negative, I'm going to get the mirror image, the reflection of it. Flip left, right. There we go. It's going to be something like that. That's my description. Now, of course, I'm going to accurately graph it, but let's see what happens. We'll see if I was right. I'll just kind of put that over there for now. And I'm going to make a table. Now, let's see here. I didn't give myself a whole lot of room to do work, but I should be able to squeak it in. All right, so I think I'm going to pick 0, and then I'll pick negative 1 and negative 2, and then, of course, 1 and 2. Remember, I chose 0 because I wanted whatever number would make the exponent turn to 0. In this case, it's just a negative x. Putting 0 in does the trick. So if I put 0 in there, the base turns to 1. I have 1 plus 1 is 2. So 0, 1, 2 is on my graph. Okay, when I put negative 1 in, I'm going to get 5 minus negative 1 plus 1. Well, that's 5 plus 2. Or, I'm sorry, 5 to the second, or 25 or 26. I'm not going to fit that on the graph. That puppy's taking off. All right, what's going to happen when I put 1 in? I'm not even going to worry about doing negative 2 because it's going to be too big. All right, when I put 1 in, I'm going to get 5 to the 1 minus 1 power, which is, oh no, excuse me. I'm making a silly mistake there. 5 to the negative first plus 1. Now, 5 to the negative first is 1/5 plus 1 is 1 and 1/5. Okay, so it'll be something like that. Okay, when I put 2 in, I'm going to get 5 to the negative second, which is 1/25, so it'll become 1 and 1/25. Pretty darn close to that asymptote. So this graph is going to do something like this, hugging the asymptote, and then it's going to shoot way, way up. And so I'm not even going to cross the line x equals 1 because I know it's going to shoot up. Okay, now my initial prediction was something like that. It's actually a little more steep than that, but the idea still stands. All right, let's try this second one here. I'm going to use that same table, although I may pick different values for x. And I'll do these points in green. Looks like I do like 0 again, though. So I'm going to put 0 in, put negative 1, negative 2. I'm going to put 1, and then 2. Now I'm going to look for the asymptote. The asymptote is going to occur at y equals negative 2. So it's going to be a horizontal line at y equals negative 2, like that. And I think this one's going to approach from below. Why do I think that? Because the base is negative, not because of the negative 2, because the base is negative right here. All right, so let's see what happens. If I put 0 in here, 6 to 0 is 1, but it's negative 1. Negative 1 minus 2 is negative 3. Now you should have already done these problems. You shouldn't be just sitting and watching me do them. If you haven't done them, please turn off the video, pause it, go and try them yourself, and then see if you can come up with what I'm coming up with. All right, if I put 1 in, I get 6 to the first. It'll be negative 6. Negative 6 minus 2 is negative 8. Okay, 1 to the negative 8, 9, 10, 9, 8. Okay. 6 squared is going to be like a negative 38. It's going to be a big number. Let's see what happens when I put a negative exponent in. So we get the negative of 6 to the negative first minus 2. Well, 6 to the negative first is 1/6. It's going to be a negative. Minus 2 is going to be negative 2 and 1/6. Okay, I'm not going to squeeze that in there. We know it goes right there. So at negative 1, I'm going to get negative 2 and 1/6. Pretty close to that. When I put negative 2 in, I'm going to get the negative of 6 to the negative second minus 2. This will be 1/36. So it'll be negative 1/36 minus 2, which is going to be equal to negative 2 and 1/36. Okay, which is going to be pretty darn close to that asymptote. And when I go to graph it, it's going to do something like that. Okay. Last one coming up here. Excuse me, I can make a little better input-output table here. I'll have a little more room to do it. And on this one, I don't think I'm going to put 0 in as my first choice. We'll talk about that in 1 minute, though. My asymptote for this one is going to be y equals 0, because there's nothing being added here. In other words, my asymptote is going to be the x-axis. So there is my asymptote. Looks like I'm approaching from above because the base is positive. I think my middle number, I'm going to put 1 in. 1, because 1 minus 1 is 0, and I'll get a 1 out. So 1, 1 is on my graph. All right, if I put 2 in, I get 2 minus 1, I get 1/2. If I put 3 in, I get 1/4, I believe. If I put a negative 1 in, no, I want to put 0 in, excuse me. I get 1/2 to the negative first, which will be 2, right? Okay, and then when I put negative 1 in, it's going to be the negative second. So 1/2 to the second is 1/4, but the negative second is 4. Hi, buddy, how are you? I'm in the middle of recording, so I can't pause it, buddy.
I want you to come play baseball.
I know you do, but I'm in the middle of a big, long video, and I don't know how to pause it, so all the friends at home are hearing us. Do you want to say hi, Happy Mother's Day to all the moms out there? Say Happy Mother's Day.
Happy Mother's Day.
I'm sure some mommies are listening. They're hearing it a day late, but that's okay. All right, I have got to go on to problem number 4 now. Dun, da, da, da. Okay, problem number 4 says Bob has $6,000 in an account, has been growing at a rate of 5.1% or 5 1/10% for the past several years. What will be the value of the account in 4 years? Well, I have this problem set up for us. If I can just find it. There it is. So, problem number 4. $6,000, the rate is 5.1%, and 4 years ago. Remember, I'm going to use the equation A equals P times the quantity of 1 plus or minus R to the power of T. All right, so A equals $6,000. What's our P? 1, we are going up, it's gaining money, so it's a positive. Now I don't put 5.1 in, I take 5 1/10 and I divide by 100, which moves the decimal point 2 places, so it'll be 0.051. Okay, plus 0.051. And it's 4 years ago, so that's a negative time. And I forgot to grab a calculator, but if you push that in, you should be able to get the right answer. I meant to get one before. Oh, look, here it is. It must have come telepathically to me, but I can't see it because it's too dark. Let me turn on the light. Okay, very good. So I'm going to take $6,000, 1 plus 0.051, and raise it to the negative fourth power, and I get $4,917.45. Now, some of you don't know how to round, and you make no sense, no pun intended. We're talking money, and the decimal comes out to be like this. Well, with money, we're always going to round to the hundredths place. This is 1, tenths, hundredths, thousandths, right? Tenths, hundredths, thousandths. We're going to round to the tens place. So this 5 will either stay at 5 or go up to 6. I'll look behind the 5, 0 to 4, 5 or more, I raise the score to 46. 4 or less, I give it a rest. So my number is $4,917.45. Okay, that's easy enough. Now problem 5 talks about population, and they say there's 1,234 people. That's my P, right? Principal. It's been decreasing at a rate of 1.3%. Well, that'll be a minus 0.013. And I want to know how many people there will be in 3 years. Well, that's a positive 3. Okay, so when I go to set this one up, it's going to set up very much the same way. Okay, 1 plus, minus, because it's going down, excuse me. 1 minus 0.013, and I'll raise it to the third power. Now, when I get this, 1, 2, 3, 4, 1 minus 0.013, and raise it to the third power, I get this number here. Okay, I get 1186.496927. Now I'm talking about people, so I'm not going to round to the hundredths. I mean, what's a hundredth of a person or 200th of a person? It makes no sense. So, I mean, even if a person is missing a limb or a digit, they're still a whole person. They're still complete. So I'm going to say approximately, and I'm going to go 1,186. And since this is less than a half, I'll go round down to 86 people. Okay, but I'm going to think about what I'm doing. I'm not just going to be a slave to actions. I'm going to think because I have a brain and it works. Okay, I need to use it. If I choose to not use it, that's my fault. But I'm always going to think about the context of the problem. It's not money. I'm not going to put a dollar sign by this. I'm not going to show a decimal because there's no such thing as part of a person. All right, where are we at here? Problems number 6 through 12 are the simplifying rads. So I'm going to take number 6 here is 40b to the 4th. And I'm looking for the largest perfect square that goes into 40, and I believe it's going to be 4. Okay, 4 splits up into 2 times 2, so the 2's leave the house and go out on a date. Okay, now there's a 10 left alone at home. I could break 10 down, but I don't get any dates because I don't get any perfect square factors. Now b to the 4th can break down as b squared times b squared. I can break it down other ways, like b to the 3rd times b to the 1st, but then I don't get any square roots. I don't get any dates. I don't have any matching terms. So these go out on a date. So there's a b squared out front. And there is my answer. Okay, let's try number 7. Number 7 says 60b to the 11th. Again, I'm looking for the largest perfect square that's a factor. Again, I think it's 4 in this case. 4 times 15. That'll be 2 times 2. And so the 2's can leave the house on a date. Who's left inside? Well, there's a 15 left inside. Okay, now the b to the 11th. Remember, I'm supposed to rewrite it as b to the 1st times b to the 10th. Then the b to the 10th becomes a perfect square, and I can write it as b to the 5th times b to the 5th. Okay, the b to the 5ths go out on a date. But when I do that, since the exponent is odd, I need absolute values around it. All right, then I'm going to have a b to the first left inside right here. And there you go. That's number 7. Number 8, there's a couple different ways to do number 8. Okay, number 8, we've got rad 10 over rad 5. Well, I can do it like this. I can write as the rad of 10 over 5, which is the same as rad 2, because 10/5 is 2. And I'm done. I think that's the best way to do it. If I really wanted to, I could have done it like this. I could have broken rad 10 down into rad 2 times rad 5, right? And then over rad 5. And then because that, I can cancel out the rad 5s, and look at that, I'm left with a rad 2. I get the same thing no matter how I do it. All right, let's move on to number 9. I know I'm going kind of fast with these. That's only because there's so many of them. You know, if you're having trouble, please go back and rewatch a video. All right, let's see here. Number 10, we've got 2 rad 6 times 7 rad 3. Now I'm going to multiply the 7 and the 2 and get 14. Under the rad, I'm going to have 6 times 3. But that 6 is the same as 2 times 3. Look at that, I have another date. Okay, so I've got a 14 out front. Now I have a pair of 3s out front like that on one date, and then a 2 left at home. Now I'm not going to leave it like this, I'm going to multiply. So it's going to be 42 rad 2 is my simplified answer. Number 11 says rad of 99 plus the rad of 396 minus rad 44. All right, well, they don't look like terms, but I might be able to turn them into like terms. Again, always looking for a perfect square, and I know that's going to be 9 times 11. There's my perfect square, 9. 3 times 3, so this is going to simplify to 3 rad 11. Now, if you've been paying attention all year, you know my trick for multiplying by 11s. 25 times 11 is 275, right? Begins with a 2, ends in a 5, and 2 plus 5 is 7. Okay, 41 times 11 would be 4, 5, 1. 4 plus 1 gets the middle digit. Well, look at this, a 396. Hey, what's 3 plus 6? 9. 11 is a factor of this. And the other number is sitting right there, 36. Ooh, look at that, I got a nice big perfect square. 6 times 6, and then times 11. There's a date. So I'm going to have plus 6 rad 11. 44 is easy enough. 4 times 11. Break 4 down, it's 2 times 2. Got a date. Negative 2 rad 11. So, 9, looks like my answer is going to be 7 rad 11. I have 3 rad 11s. I have 6 more rad 11s. I'm up to 9 rad 11s. And then I lost 2 rad 11s. So I'm down to 7 rad 11. All right, very good, very good. All right, number 12, same type of problem. Let me get a clean area to work on. Trying to do this as quick as possible. If you need to go back and rewatch part of it, you go right ahead. Last test of the year other than the final. Last chance to improve your grade. All right, we got rad 28 minus rad 32 plus rad 18 plus rad 63. All right, rad 28 looks like I got a 4 and a 7, which means that's going to be 2 rad 7. I know that's going to break up into 2 times 2. Here, I've got 16 times 2. Always get the largest perfect square I can. 16 is 4 times 4, so that's going to be minus 4 rad 2. Not like terms, won't put them together. Not going to do it. 9 times 2. This breaks up into 3 times 3. So I'll get 3 rad 2. Ooh, got some like terms there. Okay, and here I'm going to have 9 times 7. So that's going to be a plus of 3 rad 7. Oops, not a 3 rad 3, a 3 rad 7. All right. Let me see, where is my highlighter? Highlighter, where are you? Okay, so I've got negative 4 rad 2 and a positive 3 rad 2 right there. And over here I have a 2 rad 7 and a positive 3 rad 7. So let's see. The rad 7s will come out to be 5 rad 7s. And the rad 2s will be minus rad 2. Could put the 1 there, but it's really unnecessary. And there you go. All right, let's see here. Do I have room for problem 13? Where is problem 13? There it is. All right, the distance between the points. So, let's see. The distance formula is something like this. X sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. And you know, you could always cheat and plot those points on a graph and then do the Pythagorean theorem, because that's all it is. But it's good to know how to use the formula as well, because plotting 923 would be a pain. All right, so my x's, looks like I'm going to do 9 minus 8, square it, plus 23 minus 7, and square that. All right, so this is problem number 13, by the way. And I'm going to get, this is going to turn out to be 1. This is going to turn out to be 16, so I'm going to square 1 and get 1. Square 16 and get 256. So d is going to be equal to the rad of 257. Well, that answer is going to be just a smidgen above 16. In fact, rounded to the nearest tenth, it might even be 16 if I'm rounding to the nearest tenth. But I'll round to the nearest hundred just so you can see it's not actually 16 on the nose. So 257, and it's going to be 16 and 3/100ths. Now while I'm here, I'm going to go ahead and do the midpoint. I'm just going to go ahead and average the x's, so 8 plus 9 divided by 2, which is going to be 8.5, because 8 plus 9 is 17, half of 17 is 8.5. And then the y's, I'm going to go 7 plus 23 divided by 2, which is 15. And there you go, there's the midpoint. All right, let's try 14. Time for 14. All right, and I'll do it the same way. I'll do the midpoint with it as well. All right, this is number 14 now. Ooh, better change that. Okay, so I'm going to subtract. I'm going to go 5 minus negative 3, square it, which is going to end up being 64, right? Because that's going to be 8. Okay, then I'm going to have a negative 7 minus 4 squared, which is negative 11 squared is 121. So I'll be taking the square root of 185. All right, and I know 144, 169, square root of 169 is 13. Square root of 196 is 14. This is going to be in the high 13s. It's going to be pretty close to that. Maybe 13.7, 13.72, something like that. Let's see how good my estimation skills are. Take the square root of 185, and we're going to get 13.6. And I'll round to the nearest hundred again. 13.60. All right, not too shabby for not having a calculator. Not trying to toot my own horn, just showing you how simple it can be. All right, to do the midpoint, I'm just going to average the x's. 5 plus negative 3 divided by 2, which is going to be 1, I believe. And then the y's are going to be negative 7 plus 4 divided by 2, which should be negative 1.5. And there's your midpoint. Okay, now, let's see here, one more to do. And that's this one here. So I'm going to get 8 minus 0 squared, which is going to be 64. And then I'm going to get 8 minus 0, 0 minus 8 squared, which is also 64. And so I'll need the square root of 128. Okay, well I know 121 is 11. So it's going to be in the low 11s, maybe 11.2, something like that. So let's try 128, and it's going to be 11.3. So 11 and 30 100ths approximately. All right, the distance formula is going to be easy because I'm going to get 8, or I'm sorry, the midpoint formula, right? When I average the x's, I'm going to get 8 over 2, which is 4, and then I'm going to average the y's, I'm going to get 8 over 2, which is 4, and so there's your midpoint. All right, now one last problem to look at. One endpoint of a line segment occurs at 5, negative 9. So that's down here somewhere, right? We'll call that point A. The midpoint is at 8, 5. The midpoint is at 8, 5. So maybe there. That would be the midpoint. What's the coordinate of the other endpoint? It's going to be way up here somewhere, right? Okay. Well, let's see here. I know that to get a midpoint, I have to take 5 plus the other x divided by 2. And that's going to have to equal the x-coordinate of the midpoint. Well, in this case, that's 8. Hey, look at that. All I did was take x1 plus x2 divided by 2, and that equals the x-coordinate of the midpoint. All I did is plug in what I know. I know that x sub 1 is here, and I know that 8 is the x midpoint. So I'm going to multiply by 2 on both sides and get 5 plus x sub 1 equals 16, and x sub 1 is going to equal 11. All right, so the other midpoint is going to be 11. Now let's see if that makes sense. I'm 3 units away here. That's in the middle. I got to be 3 more units away. If this is at 8, 3 more units away would be 11, wouldn't it? Yes, so the other endpoint, x-coordinate, is 11. Now let's talk about the y's. Okay, I could do y sub 1 plus y sub 2 over 2, and that will equal the y-coordinate of the midpoint. Well, y sub 1 is negative 9 plus y sub 2 over 2, and that has to equal 5. So if I multiply both sides by 2, I get negative 9 plus y sub 2 equals 10. Y sub 2 is going to equal 19. And there you go. And remember, I said it was going to be up here somewhere? It sure is. It's going to be way up there. Yeah, 11, 19. And I could check it. You know, how far up do I have to go? Well, let's see. This is negative 9. And I'm going up to 5. So I think that's 14 away, right? That's a distance of 14, right? Because I go up 9 and then up 5 more. And then I have to go 14 more on the other side. So 5 plus 14 is 19. There you go. That should be the whole video for you. All right, I wish you well on your test, and I will say good night, everybody.